Colleagues, I call the meeting to order. There are still people coming in, and they will miss the introduction of our chair. I introduce Luis Fresco, Vice Chair of the Scientific Group, the Chairperson of the Executive Board of Wageningen University Research. Luis, you take over, please.
Thank you, Joachim. Distinguished participants, guests, it's a real pleasure to have you here, all of you. This is a very special meeting, the second day of 2 days for really high-level reflections on science as it underpins the agenda for our Food System Summit. I want to make 2 very brief comments. First of all, this is the first summit where we have food systems rather than just food or agriculture. And food systems, from a science perspective, means by definition that we have to bridge different disciplines. And that, in fact, creates a new challenge for science. One that's not completely unknown, but certainly one that's of extreme importance when we talk about an evidence approach to this summit and its outcomes. The second one is that, of course, science doesn't have the obvious position it used to have maybe 30 or 40 years ago. There is a growing tendency in some societies, particularly in the North, the global North, to think that science is maybe just another opinion, or that a scientist can always be found to underpin an opinion about the future or about a scientific issue in the realm of food and agriculture. So it's extremely important that we indicate that while science doesn't have the last word on everything, science itself is a progress and a process. It's building on the shoulders of others, and it will be always our best approximation of how we understand things. But of course, it has its flaws and drawbacks, and it's important that we position science and the evidence it produces in a total context. And so the challenge for this afternoon is to look at different angles of this food systems problem and see how we can actually bring science to bear in such a practical way that it's going to make the difference. Now, my first speaker is Cheryl Hendricks. So Cheryl, please take the floor.
Thank you, Louise, and thank you, Joachim and Louise, for the opportunity to try and address 3 challenging areas that you asked me to reflect on. Firstly, innovations to incentivize production of healthy diets. Secondly, how to repurpose subsidies to ensure safe food. And thirdly, on how to deal with true cost and pricing of food. So we know in terms of incentivizing healthy production of healthy food, that profit and price have been the key determinants driving food production and consumption. And over the last 4 decades, food security policies have focused on producing more food more cheaply for the growing population, particularly in the developing world. So to meet this demand, we have cut corners in many ways on environmental, social, and healthy elements. So to ensure that we provide healthy diets in the future, there are many incentives from soil health through to curbing consumption and the demand created by consumers. So a couple of examples, perhaps, of some of the incentives would be, firstly, valuing the quality improvements in soil quality that farmers and landowners invest in. So this would create co-benefits for healthy consumption of food. Many of the micronutrients are lacking from the soil, and of course the soil determines the quality of the food that we consume. A second idea might be developing an appreciation and perhaps a currency for going beyond nature positive production to nature positive and healthy food production. So an example of this could be compulsory labeling and classification of systems that help consumers to make choices, such as the coding of fishing species and catch types. Some of these are red, orange, and green, signaling the impact on the environment and on the species itself. And this would hold businesses accountable for many of the trade-offs in the production system, but also help consumers make choices. Further along the food chain, at the processing stage, so I took production to be a little bit more than just food production at the production stage, we also need transparency and accountability for the hazards of cheap food alternatives. And this requires an active engagement that we haven't seen in the past of nutrition science with businesses and policy decision makers to help. For example, we've made great inroads on the reduction of salt in food. And this is simple because you just simply reduce the amount of salt. But with sugar, we've implemented taxes on beverages, for example. But all this does is just push businesses into using cheaper alternatives to sugar. Some of them, like high fructose corn syrup, have even more detrimental impacts on our human health, particularly obesity and diabetes, because it drives the pancreas into overdrive. So we need to have a much closer tie between nutrition science and the food system actors. If I move, because of time constraints, to repurposing subsidies to producing safe foods, I'd like to focus here on energy, because this is one of the most transforming components of food systems. And it took the COVID vaccine rollouts for us to realize and expose the inequalities in the clean energy that would help us to improve the distribution of food. So here we need to harness technologies, for example, perhaps Uber refrigeration services or mobile technologies for helping people to process their food and preserve the foods that they're able to produce. If I move to the policies that reflect the true price, this is an emerging discipline, which is really enabled by the capabilities we now have of data and being able to analyze huge data sets. And here we need to look at true cost accounting in businesses and sustainability reports to make sure that we are exposing the footprints of these various agencies. But we also need consumer education in order to help consumers understand why these costs are there. But more importantly, we need to look at systemic changes, such as looking at the poverty line. And if we are to adjust these pricing systems, what effect that would have in terms of designing social protection programs, for example. Thank you, Louise.
Thank you, Sarah. That was a wonderful talk. Very rapid, very dense, beautiful ideas. I now move to Mario. I cannot see Mario on my screen. So Mario Herrero Acosta will speak to us about innovation and about the new methodologies that are at our fingertips, but not always being used. Can somebody see Mario? Is he there? Mario? No, Mario. Okay, let's move on and perhaps he will come back. Then I move to Urs Negli. Urs will speak to us about other types of innovations, in particular in relation to environmental approaches. Urs, please go ahead.
Thanks a lot, Louise, for giving me the word. I had led quite a big research institute for organic agriculture for 30 years, and there is where all my scientific experience has come from. Meanwhile, I expanded towards agroecology and developing really sustainable farming systems. So I'm honored to speak about innovations for sustainable food, sustainable and nature-positive food and farming systems. I think often scientists forget about the complexity of innovation. Indeed, innovation is a well-balanced mix of social innovation, ecological innovations, and technological or technical innovation. And this is important to see it as belonging together. We see so many social innovations at the moment among farmers, like farmer-consumer partnerships. The EU has developed the idea of living labs where farmers, people, and consumers come together and develop ideas. Then food hubs where farmers cooperate, online food shops, urban agriculture belongs to social innovations, and also all kind of increased and intensified farmer-to-farmer cooperatives and cooperations. Then on the ecological side, ecological innovation, or maybe better expressed as ecological optimization, it is about a better understanding of sustain and a better management of soil fertility, for instance, and of biodiversity. So use these natural resources in a very sustainable way, but exploit them better for human food production. And then there is all kind of technological innovations. Yesterday we talked about, it was Werner Arber, about plant breeding, livestock, all these new technologies which will become very important. Then we already talked about digitalization, but also all kind of material sciences and engineering are involved. For instance, the example given yesterday by Francis Arnold about chemistry of natural compounds. At the end, they have to be formulated, and maybe nanotechnology could be a way to formulate natural compounds in order to apply them. Or to mention another example, the latest technology is about coating, invisible coating and in order to prolong the shelf life of vegetables and fruit, and in order to massively reduce waste in households. So there are all kinds of innovation. In addition to the different levels of innovation, we have to talk about various types of knowledge. We deal with, on the one hand, understand and better manipulate agroecosystems. This is about soil fertility management, management of genetic species farm and landscape diversity, water management, and microclimate management. This is, there we have a huge capacity and potential to improve the management of agroecosystems, e.g. about plant growth promoting rhizobacteria, mycorrhizal fungi. We don't yet know enough. Then we have the category of develop best tools for farmers. So it's about new cultivars, it's about fertilizers, biofertilizer, composts, and then biological, physical, chemical pest and disease control. Only to give one example, until now we have already know about 140 40 fungus species knowing to attack nematodes, and also all kinds of cultivation, irrigation, and harvest techniques. And then finally, we need to best contextualize the farm practices, so the site-specific adapted to the geopedoclimatic conditions. So for all that, we need a lot of actors, from basic science to farmers. We need different knowledges, from scientific knowledge to tacit or indigenous knowledge. I'd like to conclude with one sentence. The most important resource is the human brain, a resource which is pleasantly reproducible. It is written by Johan Norberg in his book, 10 Reasons to Look Forward for the Future. The human brain can reproduce tacit traditional knowledge, and it can invent new technologies. This is the most important resource.
Thank you. Yeah, thank you, Urs. That's very, very true. We all agree on this last point. And thank you for this exhaustive but not final list of technologies. If Mario hasn't arrived, I move to our, I should say famous, because in my history as a scientist, the famous Ingo, who has worked so much on golden rice, which was a subject also dear
Okay,
to
you're
us.
unmuted.
Am I muted? No,
No,
excuse me.
sorry.
I apologize. Something's,
No, it's okay.
Ingo, please,
Yeah,
Professor Portegus, please take
thanks.
the floor.
Thank you for the opportunity to speak here. And I would like to warn you, be not confused. I'm reading and show you what I'm reading to be precise in time. The topic is the science and policy explainers with golden rice. It will be mostly politics. Everyone is familiar with hunger, which affects about 800 million. But let's talk about hidden hunger. 2 billion people, a quarter of the global population, are micronutrient deficient. This is hidden hunger because we lack a sense for it. As an example, the consequences of vitamin A deficiency for children are 500,000 blind and 1.8 million deaths annually. Biofortification, using the power of genetics to add micronutrients to a crop, is a novel and sustainable intervention. Since 2003, conventional breeding by Harvest Plus has increased the level of micronutrients in 7 crops, adopted by more than 15 million farm households in 40 developing countries. Dr. Howard Buis, World Food Prize laureate and director of Harvest Plus, wrote in 2006, golden rice, the first biofortified crop, put biofortification on the donor map. Golden rice, possible only via genetic engineering. I would like to stress genetic engineering provides a source of vitamin A in a staple crop. It fits perfectly the UN's first priority to combat vitamin A deficiency using locally available food-based strategies. Golden rice has been registered as safe in 5 countries so far. All required data have been submitted to regulators in Bangladesh and the Philippines. We are awaiting regulatory decisions in the case of Bangladesh since 2017. According to the Bangladesh agricultural minister, golden rice is stuck because of the environment minister. Golden rice could significantly contribute to reducing vitamin A deficiency, but to do so, cultivation, of course, has to be permitted. Golden rice will cost no more than white rice, and use will not be limited in any way. There is scientific consensus that there is no reason for GMO crop concern. 157 Nobel laureates have demanded that the UN stop vilifying golden rice. Opposition based on emotion and dogma, contradicted by data, must be stopped. Why does the UN continue to ignore the potential of golden rice? The extreme interpretation of the precautionary approach in the UN's Cartagena Protocol, together with the UN Environmental Risk Training Program in 193 countries, are the causes for the enduring societal suspicion of GMO crops. Although the first principle of the Convention on Biological Diversity, to which the Cartagena Protocol is an annex, is that human beings are at the center of sustainable development and are entitled to a healthy and productive life. And the fifth principle is environmental protection shall constitute an integral part of the development process and cannot be considered in isolation from it. The UN continues to put environmental concerns ahead of human beings' healthy and productive life. COVID has reversed the progress made towards the UN's Millennium and Sustainable Development Goals. Both food security and community health programs in poorer countries have been badly affected. There were 1.8 million COVID deaths in 2020, attracting huge attention globally. vitamin A deficiency, principally killing poor children, has been ignored for decades, although each year's mortality is about the same as COVID in 2020. The whole world, even Europe, welcomes genetic engineering to produce vaccines to fight COVID. However, the use of genetic engineering to fight vitamin A deficiency continues to be impeded by the UN. The UN should join the World Bank, who recommends biofortified crops, including golden rice, as the norm, not the exception. With very little effort, the UN could support on the ground golden rice adoption in Bangladesh and the Philippines. We look forward with UN's help to golden rice, starting to save lives, and for the proven GMO traits for iron, zinc, and folate to be added to golden rice in the future, contributing to the attainment of 6 of the UN Sustainable Development Goals. Golden rice is newly deployable science and should be part of innovation for a sustainable food system. Thank you.
Thank you very, very much. That was a plea that we expected from you, and it was as vocal and clear as every time I hear you. Professor Bagnato, your turn.
Thank you very much. I hope everybody can hear me well. Sometimes we have to pay attention because we are far from the microphone. But anyway, I want to thank you very much. Good day to everybody. I don't know if you are in the afternoon, morning, or night. I know some people are not even start the day yet. So my name is Vanderlei Bagnato. I am from University of São Paulo. I am a physicist. So I'm not a people like, especially in agriculture. I work here in the University of São Paulo. And I have a nice team with more than 120 people. And we work with optics and photonics. And we apply these techniques to problems that come to us, especially problems related to life science. And I'm going to speak today some part of our research that's related to photodynamics to improve sustainable food system. So when we talk about sustainability in food production and distribution system, we immediately think about the current problems that the advancement of agriculture has brought to the environment and the ecosystem in general. The right number of hungry people on the planet put us in a desperate position to produce more food and with higher efficiency. We certainly have to increase production and increase the disponibility of food, but not at any cost. There seems to be a great deal of challenge to produce more, produce in better way, and make food geographically available in the planet. Science is certainly the most important ingredient on it. Within several problems we face in this topic, we have pesticide abuse and its contamination to water and soil. Pesticides that are now resisted by pests. Diseases that arise from the abuse of pesticides. Abuse of antibiotics for animal use. Controlled use of water. Problems in distribution logistics, and the problem of food waste. The solution to those problems is not unique, and certainly there is still room for a great scientific contribution in the development of the solutions. In this brief communication, I would like to show you some of the alternatives that we have found to contribute scientifically to the solution of such challenges. I want to talk about the photodynamic action for pest control. Well, what is photodynamic action, right? Well, you already guessed that that is everything to do with light. Imagine that we can have certain molecules of natural origin, such as curcuminoids, for instance, which is sprayed on plants or fruits of different types, is incorporated to the microorganisms with selectivity. So these molecules have selectivity to fungi, to microorganisms, to eggs of bugs and things like this. With the action of the sunlight, those molecules provoke a photoreaction involving the natural oxygen present on the atmosphere, releasing reactive species of oxygen, eliminating pests by pure oxidation, without leaving toxicity for the plant or other side effects to the environment. That is a technique that was originally developed to treat cancer and infections in humans that now can be well applied to agriculture. Those techniques has been used as demonstration in our labs to fight various diseases such as citrus canker, fungi of many kinds, bugs in plantations, and many others with great success. At the same time, the use of photodynamic action has been used to protect all types of meat and fish, increasing its preservation by up to 5 times against deterioration. That can be an important add to food waste. The presence of biological contaminants in meat and fruits is one of the greatest dangers to consumers. The technique has allowed to decrease from 3 to 6 logarithmic scales, which means 99.99% decrease in the amount of microorganisms present in food, increasing food security. The molecules used in these cases is a curcuminoid from natural sources like the roots, the curcumin, the longa curcumin, which is a natural plant. We extract from them this molecule, and now with the help of the organic chemistry in our institute, we are able to synthesize such molecules that nature offered to us. With under the action of ambient light, besides causing the elimination of microorganisms, as I explained, also degrade themselves into smaller molecules, causing no harm to the environment and eliminate themselves. Experiments with safety in the environment using fish and Drosophila show complete safety in the use. Equivalent fruits and grains have been tested with the photodynamic action, resulting in an increase in their preservation as well as the absence of fungi that end up deteriorating those products faster or leaving behind the toxins that cause problem for the consumers. The photodynamic action with natural molecules has also been tested in coffee, orange, tomato, strawberry, and mainly vegetable crops, resulting in a huge gain in productivity without adding to the environment or consumers any risk. There is no risk for plagues and microorganisms to develop resistance to such a severe oxidation.
Okay, thank you very much. Yeah.
I just want to conclude. Can I?
Yes. One sentence.
Okay. One sentence. Okay, well, the science and technology that we are developing, in addition to having a self-content of social responsibility, allow the connection of economic with the social. We will not solve the problem of places where we needed to develop food production safely and efficiently if the economic reality of each location is not being taken into account. Good and expensive solutions are little effective and in fact causes even larger development gap for an increasingly miserable and hungry world. Thank you very much.
Thank you very much, Professor Bagnato. My last speaker for the moment is David Bolcom. Please take the floor. You are still on mute, sir.
Thank you very much, and thank you for the opportunity to address the group this afternoon. I'm going to talk about biosciences and biodiversity, particularly in the context of agriculture and food systems. And for those that don't know me, I'm a molecular biologist and geneticist working primarily with plants. So the challenge for bioscience in this context is to mitigate the well-established effects and known effects on biodiversity, bad effects on biodiversity. It's an inescapable fact that we cannot, if we are to conserve biodiversity, to use additional global land for agriculture. We need what Jules Pretty and various others have referred to as sustainable intensification of global agriculture. This is a concept that is sometimes misunderstood. It allows and accommodates extensive low-intensity agriculture in some regions where that's appropriate, but it also recognizes that in other regions it needs to be offset if we are to achieve food security by regions of highly intensive agriculture. It embodies the need to balance a strategy for land sparing so that we can accommodate wildlife and biodiversity with land sharing and land sparing. So the balance between agriculture and wildlife. So the question is, can science help us achieve sustainable intensification? And to this, the answer is yes. A very resonant yes, and we've heard the progress in science and technology over recent decades is absolutely fantastic. We heard a wonderful example yesterday about chemistry and insect pheromones. There was reference to genetic technologies relevant to disease resistance, food quality, and so on and so forth. There's also progress, we should not ignore it, in materials science affecting agricultural engineering, and also in imaging and data science that allows us to assess and manage agricultural environments. So science can help us achieve sustainable intensification. Is science allowing us to achieve sustainable intensification? And to that, the answer is not enough. The figures speak themselves. We have an extinction rate that is more than 100 times the baseline rate and so on. So what I would like to do is to propose to you two reasons why I think science is not yet achieving its full impact on sustainable intensification. And the first reason I propose is because much of agricultural research is linked to commercial considerations and intensification without the sustainable epithet to it. So yield and intensification rather than sustainable intensification. This distortion of research priorities, and we see the same distortion in healthcare, means that many important targets of research are overlooked, diseases of tropical crops, for example. It also engenders mistrust in science and technology in society. People are quite rightly skeptical and cautious about activity when corporate profit is the motivator rather than the impact on biodiversity. A second consideration is a reason why sustainable intensification is not being achieved, and we've had reference to this consideration at several points in the discussion, is a mindset within the scientific community. So science is necessarily a reductionist activity when we're operating at the laboratory bench. But when we bring our thinking out into the real world, a more holistic perspective is required. We need genetic engineers to be talking to agroecologists, to be talking to social scientists and economists, and so on and so forth. There are silos in science thinking about research and food systems, as we heard yesterday. So how do we address these problems? Well, in the long term, we can achieve sustainable intensification if our food system research is underpinned by evidence-based life cycle analyses in which we quantify the economic value of ecosystems. And this was all set out very nicely in the Dasgupta review of the economics of biodiversity that was published earlier on this year. We need to change our measures of economic success, and we need to embrace life cycle analyses that are based on real world examples with defined outcomes. And just as an aside, I mean, I've read or tried to read many reports that encourage holistic thinking in research and development of food supply systems. But these are often lost in a mist of words. And just a final point is that a second way that we can achieve sustainable intensification in the short term is getting away from the commercial priorities, is to embrace public sector funding. And many of you will be aware that the British government has recently reduced its spending on aid from 0.7% of GDP to 0.5%. This is hugely damaging for the priorities that we're thinking about today. It's having a huge impact. And I hope that we can, in the output of this meeting, send some message to the government that this is not a good thing to do. So thank you for your—
Thank you. Thank you very much, David. I will try at the end to maybe put in a few things to try and sum up. But first of all, I want to repeat the question. Is Mario Herrero Acosta here? I don't think so. I didn't see him. So my suggestion is, if you agree, we now open up for discussion. Again, I would very much like each discussion to be very brief and really present not an entire statement, but just a sort of a teaser, a question or an issue. And the first person I would like to ask to take the floor, if he's willing, is Ousmane Badiane. You weren't able, sir, to join us yesterday, and it would be really lovely to hear from you a little bit of perspective on African science in this respect. Is that possible? I know I'm springing this onto you, but I hope that works.
That's okay. Well, thank you for giving me the opportunity to join the discussion. My assistants entered the meeting wrongly in my calendar yesterday, so that's why I missed it. But I'm happy to join in the discussion around science and technology and the importance, especially in the case of Africa. I think African countries cannot be part of the global economy in the future if they don't embrace the technologies of the future. We have specific and unique challenges. Yes, the food system comprises of the same segments, but I think the segments weigh differently according to different regions. And the biggest challenge we're facing in Africa right now, and will, despite a very strong recovery, and will be facing the next generations to come, is how to expand, how to raise productivity in the rural areas, including particularly in agriculture and everything that's dependent on agriculture. It is known that you cannot reduce poverty if you don't make people more productive and to create assets for themselves and so on. So when we come to technologies, there's good progress perhaps, and certainly good opportunities around digital technologies. There's a lot we need to do, but we have somehow maybe the ecosystem for that in terms of agtech services, digital infrastructure, and Africa has been at least closest to the global average there than anywhere else. Where we have a challenge is in the area of biotechnology in general. And there I think that biotechnologies are key to three things we need in Africa. And we just heard about sustainable intensification. They're also key to reducing poverty. They're key to reducing hunger. We just heard about the golden rice. Micronutrient deficiency is rampant in Africa. So we have the problem that we often equate biotechnology to transgenic research. And yes, we do need transgenic research, but there's biofortification. There's a lot of other things that are important there. What we might want to do and need is to zero in on the capacity within Africa to harness and deploy these technologies safely for the environment and for human beings. We can be tracking laboratory capacity, we can be tracking expertise, we can be tracking institutional infrastructure, and focus on those three and see how we're moving the needle. The rest is based on science, and the science has to be created and leveraged locally. Thank you.
Thank you very much, Ousmane. That was a really important contribution. I'm now opening up again for discussion. Could you please use the functionalities at the bottom where it says reactions so that I know who wants to speak? And again, I'm going to be extremely severe and ask everybody to really limit themselves to 1 minute. I hear Mario is possibly still joining, but I think we first have a bit of discussion. Who can I give the floor? David Silberman. David, please unmute yourself.
I really like this discussion, and I think that we saw two major points. One, the emphasis on supply chain going beyond the farm gate, and the other is sustainable intensification. And the two are related. My feeling is that value chain is a transition from the innovation to the consumer, and we have to recognize that we cannot ignore commerce. Commerce is part of it. So we really need to develop this transition. And a key element in this transition is the educational industrial complex, that the universities work with industry, we have technology transfer, we have a system of innovation that move forward, we have research, development, and commercialization, and this is a key element. And if we do it, then there is a big justification for public support, for public research, because that is crucial. And I think scientists should be involved in the commercial world. The second thing is to have prices and regulations that reflect social value and are based on science. I think these are the big problems, that today our price system is not working, and this is a big challenge of social scientists to address it. Now, the last point that we have is people are worried about hunger. Hunger is not only a lack of food, hunger is a result of poverty. So we need to develop systems that will increase the income of poor people. And in this regard, rural development can be a result of rural intensification that allow us to reduce the land base, to move to the bioeconomy, and to increase the income of farmers. So thanks. I think it's really an exciting workshop, and I really appreciate what we have.
Thank you. Thank you, David. Frank Ewert.
Yes, thanks very much. I would like to follow up on the statement that David made, Wajkomp, on breaking down the silos across the disciplines in order to foster sustainable intensification. We may also call it agroecology. That's not so relevant. But I think we miss out let's say the system level here in terms of not drawing a line only around the sciences. If we want to advance with sciences and innovation in the sense that it is taken up by society, then we have to engage in a much earlier stage with society and with the skeptical, critical parts of society. We see resistance not only for biotechnology, GMO related activities, we also see that in the context of digital technologies, that there is a resistance against those developments in certain parts of society. And if we as scientists don't engage in this communication and in transfer activities in an earlier stage, I think we will miss again a great chance.
Yes, thank you. You may have heard my initial comments exactly about this. Isma.
Thank you, Louise. I want to just join the discussion to say that this year it's really quite unique. Italy just announced the Minister of Agriculture, Chief Scientist of G20 thematic, and it's innovation and technology to support sustainable food system. So here again, we have another international multi-stakeholder engagement on, again, how do we use science and technology for sustainability? And here I want to really go back to what's in nature. Nature, it's full of surprises. We don't know yet, maybe even 0.001% of it. So going back to understand what's going on in nature and getting in information to duplicate it. So soil biodiversity, we just had a conference on soil biodiversity a few days ago. And really, when we know that we have millions and trillions of organisms in the soil that could help us, so we are not using nature to produce more. And that's really what I want to say, is that we need to do more research, we need to discover what's out there, and we need to use it to produce in a more sustainable way. So the power of bacteria, the power of fungi, power of, be it in the soil or be it in other organisms, we need to invest more. And that's where I would like really that we make a statement for the UK, if they're reducing their investment, that we need more from all countries, not only from the North, from all over. And Africa has also to invest in research and development.
Thank you, Ismaël. Very good points. Patrick Caron.
Thank you, Louise. What do I take away from the different presentations since yesterday is that technology development is not sufficient. I very much support technology development. It has been very instrumental to solve and address a lot of problems, and it will be in the future. But number one, I'm confident about our capacity to invest in technology development, and COVID has demonstrated that, and the many examples have demonstrated our creativity and our efficiency in that. But history has also shown that technology development is not enough to address sustainability concerns, and that is very well illustrated by the state where we are. So we need a paradigm shift based on 3 pillars. First, a culture of sustainability, to change the action regime. And there have been, for example, by Cheryl, many illustrations of that talks to enabling environment, trade, policies, and so on. Number 2, to develop a culture of intelligence, to much better understand what are the obstacles, how to manage risk and uncertainty. And third, a culture of innovation, not innovation for change, but innovation to address sustainability concerns. That means a new ways to look at metrics and performance. And this is the only condition in which we will make technology development contribute to sustainability. And I'm not talking about such change as enabling environment or policy measures. I'm talking about the role science should play to develop these 3 cultures: sustainability, intelligence, and innovation. Thank you, Louise.
Thank you, Patrick. Yo-Sung Lee, could we also see you on camera, please? That would really enhance the contribution.
Can you hear me?
We can hear you. We would like to see you.
Okay. Somehow, yeah, I'm trying to open my video, and somehow I have a problem.
Don't worry. If it doesn't work, it doesn't work.
So I need to some work on my computer to fix this video thing. All right. Sorry, I was not able to attend yesterday as due to some other commitment, and then very happy to be here. And I also support the view about this need to have a holistic understanding of this issue, and especially the point about having a good understanding about the economic value of ecosystem services. In this regard, I think that the ecological science and economics need to collaborate further in this area. And let me give you an example. The climate damages estimates has been continuously underestimated largely due to this uncertainty surrounding the economic value of ecosystem services. Mm-hmm. Thank you very much.
Thank you very much. That's useful. Any other comments? I cannot see the whole crowd, but I think we've gone through our hands. If Mario still is not here, let me...
Louise.
I'm sorry. Yes, I cannot see all of you, and I just shifted to the other... Lisa, excuse me.
Okay, thank you very much. Thank you for all the interesting short presentations here. I just have a question to Dr. Bolkomb regarding the sustainable intensification, and how do you see the precision agriculture that is coming more and more in different parts of the world? Would that be an important part of sustainable intensification in certain areas?
Yes, of course.
Yes, thank you for the question. And I think that all technologies are part of or can contribute to sustainable intensification. The principle behind sustainable intensification is firstly that it is producing enough food for the planet, but sustainably. If the methods we're using are not sustainable, then they're not doing what we need the system to do. So sustainable is as important as intensification. And if we have to mitigate the intensification in order to achieve sustainability, then so be it. That's what we have to do. And precision agriculture, so yes, minimal fertilizers where we need them, pesticides only where we need them, and so on and so forth. This is an important component of sustainable intensification.
Yeah, exactly.
Thank you. Thank you, Lisa. If you don't mind, I'm just going to go through the next speaker, and then I'll try to wrap up as much as possible. Edward, please. You are on mute, sir.
I would just like to comment about irrigation. I haven't heard anybody know the use of water and for intensive agriculture, which has always been, from Persia to now in California, we have very examples in which irrigation produces enormous amounts of food. And so that sometimes conflicts with ecology. We are not developing new water systems, I think, to deposit water. I wondered if somebody has any ideas as to why that is, or whether it would be useful for food production to have more irrigation projects.
Thank you, Edward. Well, perhaps I can take the liberty to respond to that, because exactly irrigation or water management is very much part of this whole package of precision agriculture, and various people, including the other David here, have been instrumental in developing some of the high precision irrigation techniques. So definitely that is an area that's moving forward. So let me try and wrap up a few things, and then give, if necessary, Joachim the chance to react, and then we have a minute to move on to the next session. I think the consensus is that the key paradigm, if you want, still is, and I'm saying still because it's not new, sustainable intensification. But in a contrast, in a way, to the situation of science when that concept was first launched, we have moved forward very much in science, and we've moved forward also particularly in the areas that used to be somewhat diverse and unconnected, say chemistry and biology, physics, and so on. And in fact, that whole area has moved towards a far more precision-oriented way of looking at agriculture. Indeed, not just precision agriculture, but to really fine-tune everything we do along the food chain, including traceability, where has a product been produced, what molecules are there. We can actually trace origins, trace all the chemicals. And that kind of precision take on agriculture and food is very, very useful when it comes to quality, but also to nutritional composition. And so I would like to say that many of you have indicated that precision in some way or other is a kind of paradigm shift. But of course, this is not just a biological or physical issue by itself. The real paradigm shift, if you want, is that we embed this much better in a policy and legal and social context. And that is where still a lot of work needs to be done. The acceptability of new technologies by society is not a foregone conclusion. And actually, even although our work on genetics is much more advanced than it was 20 years ago, the acceptability of genetics as part and parcel, not just of food production, but also of the way we look at human health and human diets, is not at all something that is now more accepted. So there's a lot of work to be done there. The other area that we've touched upon is the issue, which I would call, although you didn't use the word, that agriculture and food production and food and nutrition are both global concepts in a way, but the truth is, of course, in the art of the local. It's the adaptability to local conditions, whether it's local consumption patterns, local institutional patterns, or local ecologies, that is going to be the crucial issue. And here too, the contributions of several of you have indicated that by learning more from how ecosystems actually work, we can move forward. We understand much better how control mechanisms in ecosystems work, and we can use that to direct the best possible forms of intensification with the least damage to the environment or biodiversity and so on. So in the end, the paradigm shift, if you want, is a combination of local, ecological knowledge with high-tech science. And high-tech also means the use of artificial intelligence, of data, of linking information databases, including weather data, climate that we haven't mentioned very much, all to a way in which we use the Earth surface. So in a way, I could say it's not that we have need so much for a new paradigm, but we have to strengthen the good parts of the paradigms that were there, and above all, link them together very strongly. Now, last but not least, several of you have indicated that the key issue is not so much the technological solutions, but the building of trust. Trust in society, but also trust at the governmental level, that indeed there is no policy, no improvement, no intensification in food and agriculture without trust in science. And we as scientists also have a role to play here, a role to play to make sure that the transparency is clear, that we show how we come to our conclusions, and that we also show that science is really a self-cleansing kind of process. It's the best way, I like to say, in which we organize our doubts, the best way for us to really move forward, indeed, using our brains and the renewable brain power that we have from generation to generation. So I think all in all, I hear from you an active and positive engagement. Science is there, science is needed, and science is perhaps sometimes part of a problem, but far more part of the solution. So thank you very much. And the last few minutes are for Joachim to maybe make the link between this workshop and the next.
Thank you very much, Louise. Not for only for controlling this panel in superb ways, keeping us on track, on time, but also for this splendid summary and extrapolations from what we heard into the underpinnings of the agenda which we need to develop for the Food System Summit. The Food System Summit's agenda will be anchored in the Sustainable Development Goals. We need to connect in pragmatic ways to it, otherwise we will not be listened to. This panel had excellent input into that. Colleagues, I would like to suggest we move straight on to panel B, following from this excellent panel. That panel will be chaired by Afsana, Kausar Afsana from Bangladesh, is Vice Chair of the Scientific Group and Professor for Public Health with Brak University in Bangladesh. Afsana, you have 4 great speakers. Maybe that Mario Herrero, who has just joined us, will be available. I suggest we first run through the session. Although Mario woke up late in the night in Australia, he will bear with us. I suggest you call on him before you enter into the discussion period. Afsana, you have the floor.
Well, thank you very much. And greetings from Bangladesh first, and good morning and good afternoon and good evening. And it's my pleasure to be here with all of you. And I'm so, I feel honored to be here to listen all those remarks coming from different speakers here. And in this is actually the continuation of this session 3. And in this particular session, we'll be focusing on the issues that are titled as Emerging Science-Related Propositions for the Food System Summit. And this is quite critical because we heard from Louise and from the speakers that how important science and innovations, especially as we have been thinking and talking a lot about the sustainability And this is not only talk. I think we need to act on this. And it was remarkable solution that we have heard. And I'm very pleased that we have also excellent scientists who will be presenting now. So it's my pleasure that I'm going to introduce first who I actually know very well. This is Dr. Lynette Neufeld. So Lynette, I'm not going to say that what you'll be saying, but I'll be happy that if you take over and start the presentation. But it's for 5 minutes, so I would like to be also strict like Louise. Lynette, you are here, I saw you.
Yes, hi. Hi, everyone. Thanks very much for the invitation to say a few words. I was asked to speak on the topic of innovations to facilitate improved nutrition, behavior change towards healthy diets, and empowerment of women. I'm going to take a very broad interpretation of the term innovations in my response. We need to innovate solutions, but we also need to innovate in our ways of working across communities, in our ways of measuring and tracking progress, and in our approaches to delivery. So let me speak first to facilitate improved innovations to facilitate improved nutrition. As the Food Systems Summit, we're appropriately emphasizing healthy diets. But we must not forget that care and health are inextricably linked with dietary intake of causes of all forms of malnutrition. And achievement of goals for nutrition, reduced stunting, wasting, anemia, obesity, will be fully achieved only if we advance simultaneously to address the underlying health issues that interact with dietary intake and can, for example, inhibit the body to take advantage of the nutrients that one consumes. We must also address the inequities and power imbalances that lead to inadequate and insufficient care, particularly for women and for children. Let me take a moment to speak to the case of anemia as an example. It's well known that anemia has both nutritional and non-nutritional causes, yet we continue to focus our actions in the nutrition community on enhancing iron intakes of populations primarily. Yet infection and inflammation cause the body to sequester iron, reduce absorption, and with excess iron, we actually may have harmful effects in the context of coexisting infection and inflammation. Science is evolving an understanding of these challenges and these interactions, and we must innovate in our ways of working to simultaneously address these multiple causes of anemia and not continue to progress only and think only about our silo and focusing on nutrition interventions. Bringing stakeholders together and developing joint research agendas, joint and health and nutrition programmatic guidance is an important step in addressing this problem. Similarly, there are vital interventions that save lives and address several forms of malnutrition, such as the treatment of severe acute wasting. While further innovations can enhance their effectiveness, the major constraint to progress in this regard is not minor tweaks to our approaches to addressing them, but rather the insufficient adaptation of those approaches to the unique contextual contexts where children are wasted, and the continuity of funds and commitment to address the fundamental inequalities and poverty that underlie the continued burden of child wasting. Moving to empowerment of women, I think there are others in this room that are much more expert on that topic than I am, but let me just highlight two examples. We know the importance of education for girls, yet we don't necessarily make that link to ensuring that we build those programs together, thinking about the importance of the fundamental education for girls. We also have evidence from several countries that illustrates how social protection programs that put resources and opportunities into the hands of women increase the potential for those benefits to accrue to families and to children. In going specific to the food system, in many countries, women lead small and medium-sized enterprises working within the food systems, yet we know their access to credit and the support that is needed to expand and strengthen their businesses is constrained. Back into the areas where I feel more comfortable speaking on behavior change for healthy diets. I would hazard to suggest that as a nutrition and food community, we have been complacent in this regard. We squabble over the specifics of a definition for healthy diets and what indicators should be used to measure it. And as a result, while we know that the direction of travel towards unhealthy diets is going in the direction we don't want it to, we don't have the data in many countries that we need to inform the specifics about the challenges of unhealthy diets in those contexts. Second, as a nutrition community, we have been ineffective in communicating to the world why recommendations related to healthy diets sometimes change as evidence evolves, which has deteriorated trust in science and opened the door for all kinds of dietary trends and fads. Furthermore, we've been complacent, leaving business free rein in creating demand for unhealthy foods, and they have responded to our very busy lives with a plethora of convenience and inexpensive products. And I know my time is running out. Too many things to say on this topic, but let me just highlight two very quickly. First of all, there's a growing body of evidence of the importance of ultra-processed foods as a contributor to unhealthy diets. Yet as a community, we haven't coalesced around a common definition of what ultra-processed foods are, and we haven't sat down with the food science community to ensure that they recognize that, and that therefore we can work on a common agenda to address the challenges through policy levers and incentives and other actions to really profoundly change the trend that is happening around ultra-processed foods. The evidence that it's a problem is clear. And I'll close with the other area where I think we have been negligent in regulatory actions, and that is in regulating social media. They are explicitly targeting children and youth with unhealthy foods. Many have decided to ban tobacco and alcohol and arms advertising on social media, but unhealthy foods, there is no ban, there is no regulation of social media in this regard. Thank you.
Thank you very much, Lynette. It's excellent presentation. And I'm going to call upon Professor Thomas Hertel.
Thank you.
The floor is yours, sir.
Okay, thank you very much. Yeah, I'm pleased to have the opportunity today to talk with you about food system resilience. This is the subject for Action Track 5, and I refer you to our background paper for a comprehensive discussion. Given the tight timetable, I'll focus on just two topics: opportunities for de-risking agriculture and potential for trade and markets to enhance food system resilience. As climate extremes become more frequent and more pronounced in the future, producers, indeed entire communities, will face increasing risks that cannot be insured through traditional community-based risk sharing. Weather index insurance has been developed specifically for such circumstances. Here, households enroll at the beginning of the season and receive payouts for all farmers in the drought-affected region when an index, for example, rainfall measured in the region, drops below a predetermined level. Since its inception, weather index insurance has faced challenges in reaching the poorest households, as they typically face severe credit constraints. However, recent technological innovations, including remote sensing, e-banking, and other things, are permitting index insurance to thrive in a number of key locations. In India, for example, participation in the weather-based crop insurance system expanded from 300,000 in 2009 to more than 13 million in 2013. In Africa, more than 70% of the weather index insurance programs recently evaluated are led by the private sector. One of the most successful programs in East Africa is the Agriculture Climate Risk Enterprise Program, ACRE, which has reached 1.7 million farmers. ACRE works with local institutions such as cooperatives and agricultural finance providers to reach individual farmers and aggregate them up in a manner that can be accommodated. ACRE Weather Index Insurance has allowed 3/4 of participants to access credit, which they would not have received otherwise, because now they're insured against these catastrophic risks. While promising, reaching its full potential will require education about the benefits and how this kind of insurance works, and also improved historical weather information, which is still very scarce in much of the region. Even if farm households are compensated for weather disasters, there remains the question of food availability in the wake of droughts and flooding. Here, robust markets and trade can play a critical role in ensuring food security. There's perhaps no better example that's been documented in economics, at least, than that of pre-colonial India, where weather-induced famines were common, resulting in tens of millions of deaths. However, with the introduction of railroads in colonial India, large-scale interstate trade became possible, and there was a dramatic reduction in deaths when monsoon failed, for example. Improved market integration greatly enhanced food security by allowing for timely imports from food surplus to deficit regions. Trade amongst nations can play the same role, however, only if government and private actors operate under a rules-based system with adequate information. The potential for markets to be destabilized was on dramatic display in the 2007-8 food crisis, when cascading export bans and panic that ensued led to tripling of world rice prices over a period of time, even though world rice production was little changed. These price spikes were particularly severe for consumers in the poorest countries. This led the G20 ministers of agriculture to initiate a multinational, multi-agency effort to provide improved market information. Nicknamed AMIS, this information system documents in detail government interventions in real time. What's their scope, duration, when are they due to be modified, when are they modified, along with up-to-date information on commodity stocks and production. And as a result, overreactions on the part of governments and markets to the disruptions posed by the COVID pandemic were largely avoided. Of course, it's not enough to integrate national markets. Many of the world's smallholder farmers are poorly integrated into their own regional markets. In Ethiopia, a pilot effort dubbed P4P, Purchase for Progress, run by the World Food Program, works through farmer organizations in order to better integrate farmers into regional markets by reducing transaction costs, improved information flows. A recent study of this project in Ethiopia finds that these interventions boosted spending, a natural measure of welfare of these households, by 25%. It also resulted in sharply increased investment in children's education. So this has benefited not only short-term resilience, but also long-term development and poverty reduction. Thank you.
Thank you very much. It's very important to know about this, how this climate change is in fact impacting, and also some technology and the solutions is there to if we can share among different countries, that would be really useful. I think I'll go to the next presenter, and next presenter is from Ramanathan, Mr. Ramanathan. Sorry that I can't pronounce your last name, Vidvandhar. Are you here? I can't
yes.
see you.
I'm here.
Sorry, sir, I couldn't pronounce your last name properly. Sorry about this.
No problem. My last name is Ramanathan, so you already said that.
Okay.
I'm not surprised. My first name is longer than my last name, so most mistaken which is the last name, which is the first name. I'm going to talk about climate change, the tremendous impact it's already having on food production, and how it's going to worsen a lot more in the next 10, 20 years. So just to start with the perspective, we've been living in what we climate scientists call a interglacial warm climate last 11,500 years. The climate was relatively stable, and many propose that that's what facilitated the Industrial Revolution. So they could rely on next year's weather when they plant the crops. About 125,000 years ago, it was another warm period we call Eocene that was much warmer than the last one, Holocene. We passed the Eocene temperatures in 2014. And the planet is now warmer than anything it has ever experienced in the last 150,000 years. So what's the connection between warming and food production? The first thing is basic thermodynamic laws suggest that the evaporation of moisture from our trees, from our plant, from our soils would increase. And we just finished a study showing there are 6 regional hotspots, large regions, where the evaporation is increased by 10 to 20%, and they are in a drought situation. The first one is the entire American Southwest, including California, where I live. Because of the evaporation not balanced by rainfall, just in the last 10 years, 11 million acres burned. So what is 11 million acres? Our total forest area is 33 million acres. So 1/3 of our forests are already burning. The other hotspots is the entire Mediterranean, all starting from North Africa. Amazon, I don't know why no one is talking about it. We see huge drought situation there. So that's the regions which are dry are getting drier because the increased evaporation is not balanced by increase in rainfall. So let's talk about India and where our chair is coming from, Bangladesh, which they all rely on monsoon rainfall. This is also sub-Saharan Africa. When the rain is coming, it's pouring. The rainfall is intensifying. That is also due to a predictable thermodynamic law that the latent heat in the atmosphere is increasing exponentially with temperature. So as a result, and we see that in the American Midwest, the rainfall is same or has increased, but it's pouring down as intense rainfall. What that means is taking off the nutrients, water is running off. Even in California, in the middle of the mega drought, when we get our rain, it is so intense that we have landslides. So what does this all mean? In another 11 years to 13 years, the warming will increase another threshold from 1 to 1.5 degrees. That's a 50-year amplification. And it's going to be like that every 15, 20 years. The planet is going to warm from one to the next to the next. What this means is farmers cannot rely on the past. They have to live with unpredictability and things getting progressively worse. So I would like to see, I am so honored and so happy to be included in this meeting. Thank you, Marcelo, and thank you, Joachim. We need to think about resilience. We need to think about how are we going to keep that moisture in the soil for the plants. And I think our previous chair called it water management. But we need to think about the water management in unpredictable situations. We can't look at the last 5 years and make our water management. We have to plan for this unpredictability. But I'm thinking, hopefully in about 20, 30 years, we would have stabilized the climate with all the mitigation. But building resilience and adaptation has to be brought to the forefront of discussion of climate change. Thank you, Madam Chair.
Thank you very much, sir. I think I'm going to call now to the next speaker. And also difficult for me to pronounce the names, but you have to apologize. It's Jose Anuchike. Are you here?
I'm here.
Okay,
can you
hear
me?
Yeah.
Okay. So,
did I pronounce your name correctly, sir?
José, because I'm Brazilian, so it's José, not José. José is
okay, José. Okay. Thank you.
Okay, so thank you, Madam Chair, and thank you, Joaquim and Marcelo, for inviting me for this meeting. I think it's a special meeting. It's not my area of expertise, but it's a problem I really care about it. So it has been very interesting and very illuminating all this time. My training is, I'm theoretical physicist that apply theoretical and computational tools into problems in the life sciences. That has been the history of my life on many, many, many different problems. So I think I can use this part of my training to sort of give you guys some ideas about what can be done. I think that's clearly, we are coming from this meeting, but I just want to do this opening statement, that science has to play a major role, not only in increasing production of quality food, but also to make it available to the entire world. But also, as that's done, we have to take into account, like people say, that we don't abuse the planetary resources, and we are aware of all the problems, climate change that we have. So that makes a very complex problem because we are trying to optimizing many quantities at the same time, and I think we have to do it. I want to point out that basically we are a science academy, so it's very easy for me in terms of defending basic science here. I think success in this field is not going to require just advancing new technologies, but really require advances in basic science. We are not going to solve this problem just by utilizing what we know, by making the technology we know make it better, but we have to do it by creating what's new. And that's what we are good for. That's what this academy does. Basically, the idea is to creating new solutions that can really transform the world. We know the world is far from being a fair and just place, but I think transformative ideas in science have to be able to minimize this effect. And I think food and agriculture is an area that really could use more of that. Coming as a theoretician, I want to say that network theory has played a central role in recent days in creating models to make decisions in dynamic, complex systems. And although I don't work in food and agriculture, my expertise has been more on cancer, protein folding. Clearly, the problem of food creation and distribution is a very complex model. Like I said, we deal with theoretical models, and we have been used this approach to things like protein folding dynamics and gene networks involved decision-making in bacterial colonies and cancer. These new approaches have been successful with the advent of large quantity of data, new approaches in statistical mechanics, advances in neural networks, and enormous advances in machine learning approaches. That's changing many areas in science and technology these days. Doing a literature search on the areas of food and agriculture, I think that we're still underutilizing these tools on this area. I think there's a need to grow these things. Basically, these tools are very useful in terms of optimizing conditions for growth and together with reduction of negative effects. Also, these tools are very useful to the problem of distribution how you have. The other thing that I think we have that discussion, but I haven't seen yet, and I tried to read a few papers as I went around and people can correct me. I would like to see a quantification of the problem of food and hunger in the world. What I mean, there are lots of estimates and qualitative estimates going around, but the question is, how big is the problem based on how much food we generate, based on the questions of such as small farmers versus large corporations, how food's affordable in different areas, how food's available in different areas, how we put sustainability into the process. All these things in a model of networks and complex systems can be taken into account, and they have to be quantified together. We heard people making comments about each one of these effects separately, but the question is, can we optimize this problem together and basically come with a full quantification? I think we have a lot of people of FAO here that have been trying to work on that, but I would like to see a little bit more computational modeling. I think that why I'm bringing this point, I think that the nations of the world and the FAO cannot do everything alone, have not treated that problem seriously enough. Let me give an example of because that's a question that dealing with that problem is important for not only different countries' national security, but for the peace and stability of the world as the well-being of our population. If we get the case of COVID-19, I think people never took pandemic serious enough. I have been here for the last 20 years on many medical schools, people talking about pandemics, but the world didn't deal with it in advance by saying, this sort of pandemics is something that's serious enough that we should prepare. We should be prepared if these things happens, how to estimate the size of the problem, how to probe the entire community, how to produce vaccines fast enough. We are not prepared. And the disastrous situation we're in the world show for this lack of preparedness in the world. I think the problem in food is the same, and we are not dealing with it. So I want to conclude by saying that we heard about many problems in India, in South America. People were talking about during the pandemic, the problem originally from Brazil, although I live in the US now. But we really need a world global plan, right? I think it's totally absurd that we still have hunger in the world. And that means, like I gave the analogy of the pandemics, people talked a lot about it, but they didn't do anything until the problem really came to the top. I think that's the same thing for food. The world plan is necessary because we have to deal with everybody on the planet with the same level of importance. Vaccination now is showing the example of the opening the unfairness between the rich and the poor countries. Who gets first, who has access. So basically, can we deal with this problem in an open way? So coming from computational modeling and understand, you see how much we are trying to model the world during the pandemic. We should be doing things in this very quantitative way in terms of, I just want to finish, to quantify this problem. And as scientists, as we have a quantification of the problem, can we come with solutions? And more important, think about, we all come from basic science. Sometimes the solution is not going to be to improve what we know, but really come with new solutions. So thank you for the opportunity of talking here today, and I'm really enjoying this meeting.
Thank you very much. It is very useful comments. I think I'm going to go to the presenter from the previous session, Mario Acosta. You're here, sir?
Yes, I am here, and I apologize for my delay.
No, it's fine. We have time to talk, please.
Great. Okay, thank you very much. It's a pleasure to be here with all of you. I would like to share some thoughts on innovations to develop new technologies and tools, of which there are many. Starting from a real revolution around novel technologies to improve genomics, to cellular agriculture, digital agriculture, food processing and safety, health and personalized nutrition. It's great to know that we have a real arsenal of tools for improving innovation. And let me give you at least some examples of what this could be. For example, in relation to sustainable livestock, there are now a number of real opportunities to decouple the livestock sector from land by the use of increased use of circular feeds. Hello?
Yes.
Yeah. Okay. No, sorry. Yeah. By the increased use of circular feeds, for example, there's a lot of work on producing microbial protein from reactors, the use of insects, the repurposing of food waste in many places that will lead to this necessary decoupling to reduce the potentially significant environmental footprints of the livestock sector. Apart from that, there's novel products that are really emerging, like algae for the reduction of methane, that can reduce methane production by 80%, and examples like these abound. Genomics, I think that, for example, from the plant perspective, it is critical that we increase our use of these tools that have been used for cereals in other species, as we're trying to move towards a nutrition-focused, sustainable food system. I think that it is essential that there's more significant investment in all these new techniques to improve the qualities and the varieties of fruits and vegetables, especially suited for low and middle income countries. That is absolutely essential. What I would like to say as well is that while we might get incredibly excited about all the prospects and the increased technological revolution, I don't think that there are any silver bullets. All of these will actually come with some significant trade-offs, and I think that we need to be very intentional at preventing trade-offs occurring from many of these technologies. For example, going back to the example of livestock, we might end up reducing prices, production costs. Well, that could potentially lead to a rebound and an increase in production of livestock, and there could be also leakage to other species and a range of other things. And we need to be at least cognizant of those kinds of problems when we design transition pathways towards sustainability. I think that there needs to be a very significant societal dialogue to develop culturally and ethical transition pathways. I think that there are still issues to be resolved in the deployment of all of these technologies, starting from issues around trust, transparency, and social license, issues about equity, who gets access to these different technologies, which will become essential and is central to the Food Summit. And I think that well, this kind of societal dialogue that I'm talking about is really what we're starting here with the Food Summit. I think that it is essential that we bring all the players together to ensure that the innovations really leave no one behind. Thank you. Thanks a lot.
Thank you very much. I think I will open up the floor for discussion. And we have around less than 25 minutes. So I don't see any hands. Yeah, Maximo.
Yeah, thank you very much, Chair. I have three small comments and which relate the previous session to, I think, to this one. And it's the missing concept of the market structure of how technologies and data is managed today. And I want to bring an example which I think could be useful for what we do in agriculture, which is the Cancer Genome Atlas, the TCGA, which was a combination of an investment of the National Institute of Cancer Institute of Health, National Cancer Institute, and the National Human Genome Research Institute, and which brought together an enormous amount of wealth of data across all the genome research in cancer, and which allow to convert this into a public good, and which have resulted in a huge acceleration in innovation in cancer research. I think this is a way that we need to restructure the way we manage the market structure of information of technologies in the agricultural sector, given that agriculture is a human right. And the only way we can facilitate that process of technology reaching small farmers, because the market structure of the demand is completely different to the market structure of the supply, is to try to push ideas like that one, which is a creation of a huge public good, which create huge complementarities and could create significant benefits. This is also directly related to the point that was raised by Tom Hartle in terms of insurance and reinsurance and index insurance. There are two major reasons of the failure of index insurance, which is the incapacity of the reinsurance companies to cost expected loss as a result of a damage. And that is because of lack of data. The data that you have in developing countries, no matter you use satellite data, cannot be used properly at this point to be able to predict properly the distribution of the losses. And that creates a problem. So we need to find another way to create public good of that data information. And there was an initiative with cellular towers that was proposed in the G20 of Mexico, but never flew, because that's an option by which you can basically synchronize different sources of data and be able to create this public good. And just finally, on the resilience topic that also was mentioned, which I think is central for today, for us, resilience means two things. One is to minimize the risk, and the second is to cope with the risk. But in the minimization of the risk, we need to have predictive power, as it was mentioned by one of the speakers. And that is not an easy job. To be able to have predictive power in terms of processes that are happening, and some of them inclusively we don't even have an idea of the probability distributions, is something very complex, where the combination of technology, state-of-the-art technology, and information, and trying to use artificial intelligence could be central. But that's something that will help, I think, enormously to help and create this resilience in terms of the first component, which is have more predictive power to minimize risk. Thank you, Chair.
Thank you. I'll go to David. David, floor is yours. Please unmute yourself. David.
Okay, perfect. Okay, so I think I really like the discussion, but I think that climate change is a huge priority. We have a race against time, and adaptation and preparing the infrastructure for adaptation is very important. When it comes to climate change, there is a huge difference between developed and developing countries. I don't worry about the US and I don't worry about Europe. We have a project on climate smart agriculture in developing countries, and it's really a terrible solution. Now, there are 5 ways that you can adopt. You can adopt by innovation, by adaptation, by new management practices, by trade, by insurance. But one way of adaptation will be migration. And one thing that we have to recognize, that one of the things that we have to do is to develop institutions to deal with relocation of people. Already the world is suffering from migration. How do we deal with issues of accommodating migration? So it's not enough to look at innovation, but to be very innovative to deal with migration and several problems. The second thing about climate change, that it can also be opportunity for agriculture, because if we have a precision and intensification can increase production, and agriculture can be the big thing. And we need a new source of investment in research to enhance the capacity of agriculture to be seen, and to use agriculture, farmers benefit from sequestering carbon, from solar energy and other things. And in order to this, we need to have policies that basically compensate them for there. Now, but the last point is policies, a lot of time policies and technologies are not accepted because every technology is of gainers and losers, especially when it comes to climate change. We have to think about mechanism to accommodate the losers. So if we gain, all of us gain, and we try to minimize the losses. So the message is that we need to deal with strong social science emphasis on issues of migration, issues of compensation, an issue of governance that would allow the change. We have the technology can work. Make it acceptance and make people adapt. That is the biggest challenge.
Thank you, David. I think, Thomas, floor is yours.
Thank you. I appreciated the call for quantification of food and hunger issues, and I think Joachim perhaps can respond to that. He has been organizing the modeling, coordinating the modeling effort. I'll trust him to respond to that, but that will be important to talk a little about what's been done there. I wanted to add to the discussion of climate change and food production. By my rough calculations, 95% of the research into climate impacts on agriculture is focused on plants and crop yields, and really just a few crops. However, the impacts on the people, the farm labor in particular, have been largely ignored. So we recently published a study contrasting the impacts of climate change in agriculture on plants versus people. And we find the impacts on farm workers can be more damaging than the crop yield impacts, particularly in Africa, South and Southeast Asia. They're particularly vulnerable because of that coincidence of high heat and high humidity. So the rice plant might do fine with the high humidity and even the high heat, but the rice worker, when you put together the high heat and the high humidity, they cannot release the internally generated heat. And it's a very damaging for human health, a very limiting and damaging factor when it comes to climate change in agriculture. We need to think more about the people in addition to the plants.
Thank you. Jose, I see your hand.
Okay. So thank you, I think, Thomas, for this introduction. I think the idea of climate change and food production is a very important thing. And coupling to that situation, I want to add one more question. that basically you look at Brazil, for example, and the US, where a lot of the agriculture now is being used to develop energy sources like bioethanol instead of generating food. So how do we put the question about using agriculture to generate energetic sources instead of feeding people, how much that's affect the problem of hunger? I was trying to get a number on that, I couldn't get on it. And I want to put another question to basically on the same situation. I couldn't figure out, maybe Joaquin, that we know that basically a lot of the time we are not producing food because of economical reasons. Some farmers are not producing food, lack of food. How much is basically the amount of food not produced for lack of price that's necessary to solve the hunger problem? So it's just an economical problem. We are not feeding everybody, or is actually we have a need of producing more than we can. So how much do I break the economical from the situation? And the third one is something that's very different from country to country, that I just raised the question, but I haven't heard too much the question about the large corporations versus small farmers. How much of the solution will involve large corporations, and how do we deal with the fact that in many countries, most of the agriculture is done by small farmers? How do we bring that to the balance to that discussion? Does anybody has had any comment on that?
Cool.
I'm going to go to Ismahan.
Thank you very much, Afsana. I have 3 points that I want to add to the discussion. The first one, it's really the cost of technology. So we keep saying that the technology doesn't make it to the farmer. One of the reasons it's really the cost. As a PhD student, I used to buy an enzyme when I'm at the university in Cordoba. I buy a box for $300. And when I go to the ICARDA in Syria, the same box for $3,000. And that's 20 years ago. So it's really the difference of cost. It's huge. When we talk about irrigation in Africa, it's very expensive. And that's why none of the farmers will go for it. So we need really to talk about the cost, and we need to talk about local industries, because when you dig into why is it too costly, it's transportation and this and that. So we need really to, particularly for irrigation, Africa, we have only 7% irrigated land, versus in Asia, we have about 48%. So irrigation, it's very important for Africa, but we need to develop the industry and the irrigation methodologies, not the methodologies, but the manufacturing in Africa. So the cost goes lower. Same thing goes with fertilizer. Fertilizer in Africa are much more expensive than anywhere else. So the cost is very important. I think it deserves our attention. My second point, thank you so much, Lynette, for the example on iron. It really shows how we are very much borné. We are very much in our world. And sometimes we talk about multidisciplinary and interdisciplinary, but we don't do it. We still think that the solution is only in one side. And for me, that's really a great example where we need really, as agricultural scientists, talk to human health, talk to animal health, talk to environment people. And I will push it even further that's where we need education as well. We need to change our curriculum and really make it much more inducive, that we get to know many things. I think in our era where everything is on Google or on Scholar Google, we have to do things differently. I don't see education and academia really rethinking how they are addressing education, and how do you break those silos instead of, as we are studying, we are building more silos and limiting our way of collaborating. And my last point is to what Professor Ramanathan said. It's scary to know that every 15 years we're going to have about 1 degree. That's really very, very scary. But for me, it's another argument that should push us towards diversification. We need to diversify our systems. We can't keep them really the way they are. Climate change showed us already a huge global warming that is going to be affecting most of the crops that we are producing right now. And in Africa, with the need for maize, most of the maize is going to fail because it's very, very sensitive to temperature at the flowering stage. We need really another reason for diversification. So we have it from the nutrition side, we have it from the economy side, and we should have it as well from climate change adaptation. And for that, Mario and myself and a few other colleagues are joining Pedro in writing a paper on transforming a big number, maybe 30 to 50 million hectares, to really fruit and vegetables. And we need that. We need to have the infrastructure for it. We need the seed sector to follow, the irrigation, the processing. And that's where local industries are very, very important, particularly in least income countries. Thank you, Afsana.
Thank you. Usman?
Yes, thank you very much. Yeah, I just wanted to come back to the fact that putting science to use to solve all these problems we're talking about, and we all are convinced that they are very promising and actually already on the table, very effective solutions from science. But putting science to use depends on the science solution being accessed and applied by the economic agents across the value chain. So science as the top alone is not going to solve the job. So therefore, the capacity to innovate from farms, small farmers, all the way to the end of the value chain requires skills and expertise along the value chain. So as much as you want to innovate and create these scientific solutions, we need to couple that with investment in vocational and professional training that equip economic agents across the value chain to be able to access science-based solutions and apply them. This is key for sustainability. It is key for food safety and food quality. It is key for a lot of other things we're talking about here. And we often don't talk about it, and particularly in Africa. There's heavy underinvestment in that. And that has to be one of the priorities for sustainability and finding a breakthrough in terms of ending hunger and reducing poverty. Thank you, Madam Chair.
Thank you. Lynette.
Thanks. Two quick comments in follow-up to things others have said. I really appreciate all of the discussion around data. And I just want to call out that we don't forget household dietary intake data, whether that be a robust 24-hour recall, or we look to do something much more feasible and streamlined. But all of our national data don't help us identify the inequities and inequalities and the vast distribution that happens across the population. So I just want to remind us of that and call for more of that household level data. And the second one, in follow-up to what you just mentioned, Osman, I wonder how often we require, as research donors or innovations developers, how often are we required to write a section in our proposal about plans for deployment of our innovation? And I wonder whether it shouldn't become a standard part of thinking about those, planning for deployment for upfront, in a way that we ensure that the challenges to deployment have been considered and taken into consideration in the planning and the development, but also the resources that would be needed for deployment can be planned for, and ensure that there are donors or organizations and so forth that would be willing to pick up those costs of deployment.
Thank you, Lynette. I see hand of David and Thomas. Is it from previous hand or?
No, this is done. Okay. Can I add something? Okay. The professor from Brazil asked some questions that I think we should really raise. I think first of all, we have a lot of modeling and quantification of food system, and at least in my analysis, we can produce enough food, agricultural products for food, and to produce a lot of feed, especially if you allow new technologies like GMO. If GMO was allowed in Europe and adopted in Africa, or even if it had been used in wheat, you could produce food and produce much more fuel. So to me, the potential of agriculture is much, much bigger, and we underutilize it because of regulation. That's the first question. It's not that we cannot produce it, regulation is a problem. And that's the reason that we have to attend to policy. The other thing is the relation between small farmers and corporations. We need both. And we need to be honest. Very small farmers will be very poor. So we need to provide education and we need to provide capability to allow farms to grow so they will be economic viable. We cannot say that we cannot make some people poor, rich, unless they produce value. So the challenge of education is really very important. And I think the key element is to develop human capital and to develop technology and to think about how to improve, to address rural poverty and to make agriculture a source, not of food, but a source of bioeconomy. I think to me that is our biggest challenge, because if we have an effective bioeconomy, we can address climate change, we can address rural poverty, and we can also address hunger. Thank you.
Thank you, Dave.
Thank you. Thank you very much. I don't see any hands. So, okay. So thank you very much. I think this is an excellent discussion, and we brought so many issues. And at the beginning, we started with, promoting healthy diets and how to change the behavior communications, and also some indicators that actually focusing on the health issues, that anemia is one of the issues which is, of course, a hidden hunger, product of hidden hunger, but we know that how it is impacting on health. So at the end of the day, whatever we have discussed is more or less, you can understand that, sustainable development goal is actually interconnected. So that food system that we have talked a lot, so many innovations are there, and so also solutions we can hear, but we discussed also on the climate change. And climate change is a big issue, and climate change is impacting many countries from west to east, from north to south, everywhere. So I'm coming from one of the countries, which is Bangladesh, is also impacted by climate change. So climate change is taken seriously. We know that for some years, but the solutions probably is coming slowly. But we also know the causes, and if we know the causes of climate change, so how much we have been doing there, I think about that greenhouse emissions. So I hope that in the next coming discussion, and probably in action tracks, people are discussing a lot about greenhouse emissions, but we haven't heard much of greenhouse emissions here. And this is very critical, because this greenhouse emission is actually causing problem in our country, in America, in many, many countries, Australia and other countries. We are all impacted by climate change. And climate change is also impacting our food and how we are bringing the solutions. If we can't, both are actually connected. The food system, climate change, environment, we cannot separate it out. And then the human, the people, which actually impacting. What is happening today is the COVID-19. We haven't talked a lot about COVID-19, because I'm a public health professional. I would love to talk about COVID-19, because COVID-19 is one of the things that we know that how that COVID-19 is coming. And pandemic has been occurring, in Asia and also in Africa. We have seen that, some, probably not pandemic, but Ebola has happened, and then SARS has happened, and HIV virus also impacted. But we can see that after 100 years, if it is so that the pandemic, we know that this is coming, that why we are not, taking any cautions and not warning ourselves that, if we do this kind of things in the earth, and that is going to impact not only the health, not only the disease, not only the nutrition impact, not only agriculture, food production, it is, devastating the whole economy of the society. And not only the economy, the education system, everything is being impacted. If it is so, I think the science and scientific evidence is so important. And that's one of the reasons that I'm so happy that this scientific group is actually working so closely with the Food System Summit to give the solutions. and giving them the evidence. And evidence is so critical for us to take into consideration. And now we can see that slowly, because I'm from Bangladesh, and I can see that the country is actually taking actions following the evidences, not always, but it's seemingly that, you know, the science is coming close to the policy and for the practice. And that should be a continuous process. And I'm very, very hopeful that we should not be stopped ourselves. Whatever criticism comes, whatever controversies arise, we should continue to bring the challenges, show the gaps, and also the solutions, because at the end of the day, we need to have a society which will be poverty-free and inequitable with equity, dignity. And yesterday we heard from Marcelo that, you know, food is for dignity. And I always feel that every society should have the dignity every human being should have the dignity in their life to live. And that means we have to have all the rights to food, rights to education, rights to health, rights to water, sanitation, everything. And if it is so, we need to all work together. And food system is one of the systems that that Food Summit, I'm sure that it is not, it's the beginning, it's the continuous process, and it will continue, evolve, and bring more innovations for the world to have a peaceful and happy society in future. So I'll stop, and I'll also request Joaquin, if you would like to say a few words for the session.
Thank you so much for wonderful summing up, and for really reconnecting to yesterday's early commentaries from Marcelo, from Werner, from the keynote speakers in the afternoon. So very well done, and thanks to all of you who contributed to the session. I just want to add a technical remark, because Tom left that open. Tom, the global leading modeler, pushed the modeling question to me, being a much simpler modeler than he is. Jose, your question was very much to the point. But I can tell you that we have in this group here at the virtual table a splendid group of modelers who try to combine, or actually do combine, agronomic and crop modeling with systems, computable general equilibrium modeling. That's what Maximo does with his team, and integrating climate models and biodiversity and ecosystems consequences, and all this mapped into outcomes at people well-being, welfare, food and nutrition situations, and income situations. So I would love to get you back in, Jose, when we are a bit further along in the next couple of months, because your questions were well placed. That you challenged Maximo at FAO by saying in passing that FAO cannot do everything. He, of course, would disagree because he thinks he can do everything. But we need this quantification, which you are calling for. And we are pushed by the UN leadership and the leadership that organizes the Food Systems Summit as a scientific group to quantify solutions. This is the first time that the UN is organizing a food summit in which the scientific community is called to task. And we need to deliver in order to be taken seriously in the follow-up to the summit. So I thank you very much for all of you for the great presentations. Mario, it was great to still get you in. I will come back to an attempted little summing up after we have listened to our next presentation in this session, where we take first a perspective from Sir Martin Rees, He is a member of the Council and of the Pontifical Academy of Sciences. Martin is a British cosmologist, astrophysicist. He is the 15th Astronomer Royal, and he was Master of Trinity College and President of the Royal Society. Martin, I bring it into the open that you are a reluctant participant in this conference because you felt you are so far removed as an astrophysicist from the food system down to Earth. But I insist that a space perspective have changed our view, our worldviews. And I know you as an extremely creative thinker on the long run and on the future. Martin, you have the floor.
Well, thank you, Joachim. I blame you for this talk, not myself. But food supplies are indeed far from my expertise. But I am proud to be on the Pontifical Academy's Council, and I'm honored you've invited me to make some brief comments from a broader perspective. First, a few words on the overall landscape of science, as it were. Science has two fundamental frontiers: the very small, atoms and particles, and the very large, the cosmos. But these frontiers involve less than 1% of scientists. 99% work on the third frontier, the very complex. And even the smallest insect, with its layer upon layer of intricate structure, is far more complicated than a star or a galaxy. So I defer to everyone here who is tackling systems far more complex and far more urgent than my own specialist concerns. And I speak really mainly just as an anxious member of the human race. Our Earth has existed for 45 million centuries, but this century is special. It's the first when the main threats are induced by one species, humans. We're deep in the Anthropocene. We have an ever heavier collective footprint on the planet. We're empowered by ever more powerful technologies that can be hugely beneficial, but which, if misapplied, could trigger catastrophic setbacks to civilization. And such events would have global consequences. We're so interconnected that no continent will be unscathed. And for this, COVID-19 has been a wake-up call. And the world, of course, getting more crowded. 50 years ago, its population was below 4 billion. It's now about 7.8 billion. But doom-laden forecasts by Paul Ehrlich and the Club of Rome 50 years ago proved off the mark. Food production, as everyone here knows, has kept pace with rising population. Famines do still occur, but they're due to conflict or maldistribution and not to overall scarcity. And the number of births per year is now actually going down in most countries. It's peaked. Nonetheless, world population is forecast to rise to around 9 billion by 2050. That's partly because most people in the developing world are young, they yet have children, and they live longer, and the demographic transition hasn't reached some of the poorest countries. So avoiding mass hunger will require further improved agriculture, low-till, water-conserving and GM crops, and maybe dietary innovations, converting insects, highly nutritious and rich in proteins, into palatable food, and eating artificial meat and not beef. But to quote Mahatma Gandhi, there should, and that's the message of this meeting, be enough for everyone's need, if not for everyone's greed. Optimists say that each extra mouth brings 2 hands and a brain. But there are worries. Geopolitical stresses are surely concerning, because those in poor countries now know via the internet, etc., what they're missing. They're not fatalistic about the injustice of their fate. And this is a massive geopolitical concern. And another thing, if humanity's collective impact pushes too hard, the resultant ecological shock could wipe out many species. We'd be destroying the book of life before we've read it. And already the biomass in humans, cows, and domestic animals is 20 times that in wild mammals. And chickens and turkeys outnumber all the world's wild birds. Biodiversity is crucial to human well-being. We're clearly harmed if fish stocks dwindle to extinction. There are plants in the rainforest whose gene pool might be useful to us, and insects are crucial for the food chain and fertilization. But preserving the richness of our biosphere has value in its own right, proclaimed in the encyclical Laudato Si. And to quote a secular sage, E.O. Wilson, mass extinction is a sin that future generations will least forgive us for. So to avoid massive encroachment on natural habitats, then as David Balcombe emphasized, sustainably intensive agriculture must be a goal. Moreover, all these pressures on the environment are aggravated by anthropogenic climate change. Under business as usual, we can't rule out later in this century really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland's ice cap and rendering large domains of the world uninhabitable. That's why developing clean energy systems, carbon-free generation, more efficient storage, and efficient grid distribution is another global imperative. Indeed, it's hard to conceive more inspiring goals for young scientists, technologists, and engineers than to ensure sustainable food and energy supplies worldwide in the coming decades. This year, we see not only the UN Food Systems meeting, but also two other crucial UN conferences, climate change in Glasgow and biodiversity in Kunming. And the case for urgent action at these is compelling. But politicians won't prioritize long-term decisions unless there's public clamor from their voters. So scientists must enhance this clamor. We must engage with NGOs via blogging and journalism and by enlisting charismatic individuals to amplify our voice with these concerns. Pope Francis's 2015 encyclical had a worldwide influence in the lead up to COP20 in Paris. There's no gainsaying the Church's global reach, long-term vision, and concern with the world's poor. And it's welcome that his sentiments are amplified now by many others, most prominently perhaps the diverse trio of David Attenborough, Bill Gates, and Greta Thunberg. It's encouraging to witness more activists, especially among the young. Their commitment gives us ground for hope. Finally, going out to the cosmos, I offer a few cautionary words about our cosmic habitat. During this century, the entire solar system will be explored by flotillas of tiny robotic craft. But will people follow them? A few may, but don't ever expect mass emigration from the Earth. I know that Elon Musk has said he wants to die on Mars, but not on impact. That's fine for him, but it's a dangerous delusion to think that space offers an escape from Earth's problems. Coping with climate change is a doddle compared to terraforming Mars. There's no planet B for ordinary risk-averse people. That's why we must cherish our earthly home. Indeed, the cosmic perspective actually strengthens our concerns about what happens here and now, because it offers a vision of just how special the Earth is and of how prodigious life's future here could be. In the aeons that lie ahead, even more marvelous diversity could emerge. The unfolding of intelligence and complexity could be still far from its culmination. But if our generation are poor stewards, if we are poor ancestors, as it were, we'll not only jeopardize the welfare of our children and grandchildren, but risk foreclosing vast potentialities in the longer term for our future. Spaceship Earth is hurtling through the void. Its passengers, all of us, are anxious and fractious. Their life support system is vulnerable to disruption and breakdowns. But there's too little planning, too little horizon scanning. We need to think globally. We need to think rationally. We need to think long term, empowered by 21st century technology, but guided by values that science alone can't provide. So let's hope all these sentiments will gain traction in the UN conference and in what's going to be a crucial year for these issues. Thank you very much.
Very well.
Martin, thank you very much. Thank you very much for so directly connecting to the agenda, the worldview issues, and the long-term perspectives which need to be on our mind in the run-up to the Food System Summit. So thank you very much. Colleagues, I can permit 3-4 questions to Martin Rees if you would like to follow up on his lecture. Let me pause for a moment. Who would like to ask a question or give a comment or add to Martin's discussion? No Planet B. Passengers, you stay here. And Martin, thank you for bringing in the value aspects. So important. That this has to come from this group, this so-called scientific group and its surroundings. We have a lot of debate currently about a rights-based approach to a food system and rights of a healthy diet, clean water, and so on. We talk too little about responsibilities. And I think that is very important, is that we have a value-based approach to the Food System Summit.
Yes.
While I'm rambling on, I was hoping that someone would dare to challenge Martin, but you get away without challenge.
But can I just
There's no way of challenging him. He's correct.
Okay. Martin, please follow up.
Well, can I just say, again, with great diffidence, that obviously we are very concerned about the inequalities, not only within nations, but between them. And surely the reason why perhaps we need, especially in Europe, to be concerned that the countries in sub-Saharan Africa don't fall behind is that it's not only in their interests, but in everyone's interest to ensure that they have adequate food, etc., and can participate in the world economy. I'm diffident because there are experts on those areas here, but I think people have talked about a mega Marshall Plan like there was for Europe after World War II. And given the difficulty which some countries will have in rising out of poverty, because one ladder has been kicked away, namely the ladder of cheap manufacturing, which helped the countries of East Asia, the Asian tigers. Robotic manufacturing has taken over. So I don't think that countries in the Middle East and Africa can develop that way. So there's got to be some other way of ensuring their economic development. And I also think that a very strong reason why wealthy countries should prioritize research and development into clean energy and all that goes with it, storage, etc., is not simply to reduce their own emissions, because in the UK, my country's emissions are less than 2% of the world's CO2. But if we can really help other nations which need to have a higher per capita energy production in the future, India only has 1 ton of CO2 per year, whereas we have 10. They want to have more energy, and we can do far more good to help to hold down global CO2 emissions if we can accelerate the transition of those countries to clean energy, just as they made the jump directly to mobile phones and never had landlines. They've got to jump directly to clean energy. And if we in the wealthier countries can help them to accelerate that transition, that'll be a more important contribution to zero carbon in 2050 than anything we could do for ourselves.
Thank you, Martin. I know that Luis has to chair a board meeting in 15 minutes. I see a hand up from Ismahane and Afsana. I would like to proceed as follows. I would like to give you, Luis, the floor. Then I would like to have your indulgence and listen to a few summing up and way forward remarks from me. Then open it up again for comments which could reconnect to Martin anything else that has been said in this workshop. It is a workshop because it has that name because we need to work after we have shopped here. Luis, you have the floor.
Thank you very much. Also, thank you, Professor Rees, for bringing us the right planetary and cosmic perspective. I do want to put one footnote to what obviously is a very long and will be a very long story, way beyond our existence as human beings, of course. If you look at the future demographics, Martin, by 2080, population rates overall, with the exception of Africa, will actually decline quite rapidly. Even for China, that's already the case in 2060. So the idea, not that you mentioned that, but the idea that the public at large has that population will even grow exponentially, for most people who don't know what exponential means, is an incorrect idea. Our problem will actually be to deal with a much smaller population and still provide the level of economic development that we have today. Secondly, we are doing so much better than 50 years ago, whether you measure it in terms of outputs per unit of resource, land, water, fertilizer, etc., etc. There is an enormous growth thanks to scientific development in the way we can produce better with far less impact on the environment. And I'm very convinced that, for example, for Africa, there is a chance to make a quantum jump, for example, immediately to solar powered irrigation and double the yields there. So I'm not as pessimistic. I'm quite convinced as a scientist that we can feed the world with far less damage, and that our concern should not be a kind of overall dramatic or dramatized idea that we're not going to be able to do this. But what it does need, as the others have said, we need investment and we need public support for science. Thank you.
Thank you, Luis. And have a great board meeting in a moment when you have to leave us. Colleagues, I have sent you, all of you, before this meeting, a zero draft of a statement. We need to work towards an outcome statement, which is just one milestone towards what the scientific group and its partners, here the Pontifical Academy of Science and the Inter-Academy Partnership and others, are considering to put on the table from a science and science policy perspective. Not the overall summit agenda, I emphasize, but on the science and research innovation agenda, which we all consider so critical for the Food System Summit. I would like to share my screen and come up with a few points, which I would like to spend really not more than 5 minutes on. The way forward thereafter is that we are not discuss it here, overrunning our time, but that you all send us back to the long version, which I have sent to you. The long version, which I've sent to you. This is digested and cut back, this version, and give us comments at that, on that document. The points which I have digested while we were talking today have, number one, we stress all science, natural science and social sciences, basic and applied, can and must make significant contributions for the needed food systems transformation because of food systems growing complexity and the SDG challenges. Secondly, investment in science and innovation must be accompanied by institutional and policy innovations. Each of these points has been elaborated with a few sentences in the long version, which I've sent to you, and I don't want to read through the long version. I've added a few things which came up today, but not all of them. Third, bioscience innovations to develop new technologies and tools have been emphasized a lot by us, including the related regulations. Fourth, advance in digital innovations and engineering need to be focused more on the poor and serve resilience. Fifth, climate change calls for science and technology innovations and attention to the environmental and water systems consequences. Sixth, science innovations for productive soil and land and water utilization and to protect the genetic resource base and biodiversity, emphasized by many of you. I put in a point on blue foods, which has not come up that much in our workshop, but which around us is emphasized more and more. By the way, these points are not only derived from what we heard at the workshop, but they are pulled from statements and papers of the scientific group, the Pontifical Academy, and the Inter-Academy partnership documents which were shared with us. 8, trade and policy innovations to incentivize availability and affordability of healthy diets, and addressing the information distortions which you, Lynette, brought up in this meeting forcefully. Repurposing subsidies towards supportive investments to ensure food prices reflect real costs, which has been emphasized in various speeches. Efficient social protection to accompany the market-based and investment activities. 10th, boost the skills emphasized by you, Usman, and others. Focus on rights, strengthening rights, and foster behavioral change towards healthy diets. 11th, a strong emphasis on resilience investments, managing the risks and the crises, a call for policy innovations and risk management insurance. You, Tom, and others have focused on that. 12th, innovations to finance the food system transformations, a call for a specific investment need for at least 1% of GNP for food system science. Many emerging economies don't reach that. 13, strengthening the science and policy interface at local, national, and global levels, considering an intergovernmental or international panel on food systems. And last not least, improving data on all food systems components and on actors, on methods, models, tools, quantification, international sharing of science and joint education programs. Colleagues, this is a meager summing up of the key points that with which we entered the workshop and which we enriched in this workshop. It will be in your hand. I want to give you until Tuesday evening next week to help us strengthen the statement, which we will then recirculate after a synthesis done by the vice chairs of the the scientific group, and I want to include you, Volker, for the Inter-Academy Partnership colleagues, Marcelo here from the Pontifical Academy and others. But all of you have an opportunity to edit, subtract, change, delete, contest, and then the next version out there, we ask you to endorse or take issue with. And then we put it on the website of the scientific group and the Pontifical Academy of Science. Let me stop here. We have 5 minutes for closing reflections from anyone who would like to come in at this stage. And there were a couple of hands up earlier. I believe, Ismahane, you had your hand up. And who else did I block before I started? So there is...
I think there was Afsana as well, Joaquin. Myself,
okay.
I wanted just to thank Dr. Martin for really an inspiring speech and very poetic as well. And I want to say maybe it takes that you leave the planet Earth to be so sober and poetic. So it was much to say that. So you got that to see it from outside. I wish I'll have a chance to really leave the planet Earth and see it how it looks from outside. But
Ismahane, you should keep in mind, maybe we can entice Martin to join us at the Scientific Days, July 8 or 9, where we have a huge forum with stakeholders and science communities in the run-up to the Food System Summit. Your inspiring talk. I'm afraid we will have to bother you again. Now I would call on Eddie and then on Jose. Edward?
Yes, I wanted to say that we should have this positive message from Martin Rees and which we discuss in the Academy frequently, that we're at a moment of crisis in which we have 7.8 billion people, but we will have 9 billion by 2050. But after that, the world population is going to decrease. So agriculture is in a crucial period in which then feeding the human race will decrease by natural means. And I found very profound what he said. We should make the jump directly to solar panels and digital access to agriculture for the farmers, like we did the jump from mobile phones to without any landlines. I think that's a very deeply optimistic message, that thanks to Martin, and that you should include it, I think. Because we're over the hump, and then it's going to go down, the human population. And I think most people are not aware of this.
Eddie, well said. We are the only generation, all of us in this call, who lived through the inflection point of the erstwhile exponential growth curve. But the maximum is still coming. So we have this critical 2-3 decades ahead of us where we have to struggle with. Jose, you're next.
I just have a couple comments. I think that was very inspiring, the talk by Martin. I'm still thinking about all the comments now. But just to raise the point is, I think in the next decade, not only you have to do the jump on new technologies, but new technologies will appear. So you have to be prepared to almost real time, getting some stuff from basic science into solutions of the problem. I think we are seeing that on the vaccines and stuff like that, where people just developed the mRNA technology, they went to vaccines in a real, so the time from basic science and application is very short. I think that was very clear on Martin. So I think this jump, we have to be prepared to do that. Second, I think this entire problem is coupled to education. So I think we really should have reinforce the bullets that basically the food problem will solve with education of people. People are saying about new jobs and how people make money and things like, and even how you do agriculture, you don't do that without an education. So the fact of the responsibility of educating the entire society more and more for this new world, I think we should basically stress that in our document.
Yeah, thank you so much. Education for girls is the demographic game changer. Education for science will change the game which we are here for, mainly facilitating a sustainable transformation of the food system. Colleagues, we are on the dot of 4:30 p.m. Rome time. I'm here to thank you all. As I said, the game is not over. I sincerely ask you to follow up with your comments on the draft statement. We will take our time after we have gotten your feedback by Tuesday evening. You will see a revised version. This is a critical moment in the preparation of the Food Systems Summit. We have until early May, mid-May, not much more, to influence the thought process of the summit agenda. We yesterday evening had a meeting with Agnes Kalibata, who addressed us yesterday, mapping out the pathway towards the so-called pre-summit and summit. Governments need to take their time to reflect on the complex agenda which we discussed here. They require a skillful strategic aggregation and prioritization. We cannot come up with 15 points. We need to prioritize what I have shown you. For the science community, we are doing fine, but for the policy leadership community, we are not. So that in order to feed into that, we need to come to closure in our processes very quickly now in the next couple of weeks. We still, I mean, science goes on into the next decades and into eternity, Martin. But for lending our messages to the Food Systems Summit, we have a window of opportunity that closes soon. Now I close this wonderful workshop and thank you very much again for your participation, your engagement, your contributions, and ask Marcelo to have a few final words. Marcelo, go ahead.
Oh, thank you. I learned so much. I'm very interested in all the presentations, and especially Martin was fantastic conclusion, we can say. But I want only to come back to my two ideas in the beginning. We ask God every day to give food in our prayer, no? Many times a day also. The bread, today bread, and because the bread is for the body, but also for the spirit, for the human dignity to all people. But at the same time, so the first thing is we need to pray. We need to pray God to give the bread. This is common of all religions. I think this is a more important prayer that we have in the Christian religion. But also we need to follow the idea of St. Paul. We need to work, because St. Paul say the people that not work should not eat. That is very strong statement. So work to avoid problems, and especially the problem of the virus, the new virus, the virus that we have today, and the climate change, and work to innovation. And in this sense, we need to copy the evolutive mechanism of the nature that was very well illustrated by Albert, and the application that, the model application that do IGNO is a real model to innovation. I think that we need to follow this way to work, to have food. And but also we need to have hope in the future, of course, because God exists and is provident, and we think that he wants to continue to supervise all people. But we need to help God to arrive the food to all people. Thank you very much. Thank you, really, President. And congratulations for the President that was the person to personally organize this meeting, and with great work. So really it's a model of also of work. Thank you, Joachim, for your work. Incredible.
Right.
Thank you.
Thank you all. Thank you, Marcelo. Bye-bye now.
Bye.